to 14. So all the presentees, I welcome you for the first session, and I welcome you the session chair, Dr. Naveen Garu. The first paper which is going to present now is Smart Traffic Control System using CNN and YOLO. I invite the presenter to present your paper, and your time will be allotted for 10 minutes. Each participant make use of these 10 minutes. So more precisely, you present your findings and the methodology which you used to get the results. Now I invite the presentees to come forward and present the paper.
Good afternoon, everyone. I hope everyone is doing good. So I'm going to present you a topic which is actually a really interesting one, which is called Smart Traffic Control System using CNN and YOLO. And to describe this, basically, we use a traffic control system, right? Everyone knows how traffic works, right? So we have implemented a method where we can use CNN and YOLO algorithm to make sure that the traffic can decrease and make an effective use of this way of moving into a zone which can affect a low traffic blockage, and also high speed of vehicles where they don't need to stop and easily communicate and go. Okay. Learning basic traffic control algorithms have recently explored as an algorithm and existing of a traffic ecosystem, right? So real algorithms, or RL, most precise algorithms that we are using them are usually based on only CNN, and we use CNN as CNN to see where the images are present, right? So So YOLO. So YOLO stands for you only look once. So as we know that, even as explained before, in the medical industry they are using robotics, right? And now we are using a AI algorithm where they can understand and capture the screen of vehicles and describe it in a square block. See, if we see here, we can see that a car and a truck and a bicycle are denoted as the required items, and they are giving the preposition that okay, this lane is filled or that lane is filled. So by this we can make an accurate assumptions of where and how to represent the traffic and to move forward according to this. Characteristics of YOLO. So before I get into the characteristics, let me tell you one thing. Before, when we used to, before the traffic police everyone are there, it was done manually. So even if you see now, traffic police do control the traffic, but in the olden times they used to use the switches of the lights, and they see the traffic lights, and they usually manually do it. So now with this, what we can do is we can see that the capturing. We can see that where the traffic is and where the vehicles are going, and will capture through conventional neural network, and it will give us a real-time image. So this real-time will also help us manipulate the way of how traffic works. So let us take an example. We know that in India we are having a lot of traffic, whereas in the Australia we can see how they manage with the lines, right? And also the traffic control is really good. Unlike India. We don't have like traffic police or traffic certain people where they have to use the traffic police to adjust the lanes or to remove the traffic. They can, so let us take one more example to be precise, okay? So if an ambulance is in India, it might take 10 minutes to reach a nearer hospital, whereas in the US or whereas in any other places, we can see that they are giving us a local driveway where ambulances can go through within seconds, and we can see through the broadways of the roads, they can easily manipulate their way through it. But in India, we are having a really bad traffic communication places also at the same time, where it might take some time to move through the traffic for them to reach an hospital. So with this, we can, with the conventional neural network and YOLO, we can use the camera systems to capture the real-time entities, and we can also manipulate the way of I mean, we can actually manipulate it because we can actually give them a real-time stopping, and then also giving them, you know, a way to go through, because we can actually see that when we are going into a vehicles, we can see a timer, like 70 seconds or 80 seconds until a vehicle can go, or until a passageway can clear through, right? Sorry, one second. So we can see that with the timer we can actually with the timer we can see that they will have each lane separate timings, and with the separate timings they will go through it, right? So that is actually help of YOLO and CNN algorithm. So YOLO, it's not you only look once. Okay, so a camera can capture anything within a second, right? So we use high definition cameras where for the system tracking also. So let us take an example. Suppose someone crossed a red light. So we'll get the information of the person through the camera, and we can easily zoom in to which person or who was driving the car, as well as we can get their number plate, and we can get that information, personal information on who bought it. So that is one way of using it, and the other way of using or capturing is that let us take an example where India has banned the tinted plates of the cars, right? So even they use camera capture techniques with YOLO and CNN to capture them, and to also give them a fine. And so let me talk about the existing system, okay? In existing system, manually we needed to control. As I told you, we used to do it manually. We used to flick the switches, and we used to, the traffic police used to clear the way for the other people to go through. And we had to wait 100 seconds. Usually in the year of 2018 or 2017, people usually in the area of Kottapet or in the area of Dilshanagar, we used to wait 100 seconds to 80 seconds to move through the other lane because of the red light stopping or the traffic jam, right? So, and with this, we can actually manipulate the different locations of the traffic cones or traffic lights location, where we can easily make way for the other people to go through. The existing system disadvantages are all 4 junctions will have the same time period. So the olden days, as I was telling, we had to do it manually, right? So if we had to do manually, all 4 junctions, suppose if it is an X road or any road, all 4 junctions have the same time period. So if a person is going from right to left, he has to wait 110 seconds. If a person has to go from right to a U-turn or anywhere the direction, they have to wait some amount of seconds to go through. So now the system that we have proposed, as I have spoken, YOLO algorithm, which will define the person's way of looking, and which will also define the way that a person has to go through. Advantages of proposed system. Automatic based objects in the image, we can control the traffic. So as I told you, YOLO is a real-time analytic capturing device. So it can capture how many vehicles are there, and what are the heavy vehicles are there, and is there an emergency on the road. So with that, we can manipulate the traffic with using traffic lights, and also we can use loudspeakers, or at the same time traffic police. By the information captured by the cameras from the YOLO algorithm and CNN, the data will be transferred to the traffic police, and they can easily manipulate to which side of the way that the traffic is, and how fastly that they can determine a one's location to move ahead. System architecture. So if suppose there is a location where there is a traffic is held in the state, okay, and we'll get the action done, and the environmental will be giving us where we have to move them or where we have to relocate them. So with this, we'll get to know that how a particular way of operating will be done. So in the data flow diagram, we can see traffic light data collection and training data set. So we have to first, we cannot directly implement the whole process, right? So we have taken a data set from online, and we have seen and also captured some videos and taken some videos to understand the flow of the traffic better. So if we randomly said that, oh, we can manipulate it and do it like this, we will not have any proof, right? So the user here is a camera, basically. Sorry for that. User will capture the image and upload it, and it will get an image AI. So with that image, we'll see the optimum results for the division of the traffic, and with that, we'll take a course of action with it. So suppose if we are having, if we have taken some data set of images where we have seen traffic and restriction of areas because of construction as well. So if there is a construction period ahead, we cannot easily move to that area. So what we can do, or we have implemented, is that we can use that real-time image. Oh, there is a construction area ahead. So we can manipulate them and move them to a different location of the time. Different location, sorry, not time. So we have taken an images of hundreds of images where we can see how the traffic is held. I gather comprehensive data set of traffic images as well and video footage, as I have told you before. The pre-processing of the collected data set to ensure the quality of the sustainability training CNN model. So because to capture it, we have taken multiple cars and multiple vehicles of sizes as well and implementing it. So the YOLO algorithm in the CNN model for the real-time object detection. With CNN, we'll get the real-time images, and with YOLO, we can determine where the vehicles are. Okay, optimizing and fine-tuning. Fine-tune the CNN model with the YOLO algorithm. So with the, if we optimized it, we can, yes sir? Sir? Okay. So in here we can see we have given them an input of where the traffic is, lane 1, lane 2, lane 3 and 4 lanes. Okay. So we have given them that this is the amount of vehicles, or this is the amount of people that the vehicles who are driving at that area. So we can see that in the signal 1 we have to wait 326 to 978 seconds as the traffic is very heavy, and at the same time we can see at the signal 3 it is only 18 seconds because they have an easier way of directing and molding their way to the other lane. So in conclusion, what I want to say is that using CNN and YOLO algorithms, we can manipulate the traffic inputs and also manipulate the location of how and where a person should be, and a person can take a diversion of the route as well. Thank you so much.
Any questions?
What is your name?
Sir?
What is your name?
Nishant, sir.
Nishant. Nishant. Okay, Nishant. Good that you have presented the topic like traffic control systems.
Yes, sir.
I have a couple of questions here. What do you mean by manipulate? You're saying you're using very often manipulate,
yes.
manipulate. What is it?
Yes, I have used the word manipulate to manipulate the way of how a car can go in a direction, sir. Suppose,
do you want to change the lane or the route, or you want to manipulate something?
No, changing the route, manipulating the traffic lights, sir.
Manipulating is not the word, I think. Check it once.
Okay, sir.
Second question, like you want to control the traffic. Okay.
Yes, sir.
Is it in a street or in junctions? Because you're talking about the time at the junctions. Okay,
yes,
where
sir.
street light, traffic control lights will be there.
Yes,
okay,
sir.
the timer. Okay, and you're saying about streets. So which one you are concentrating on?
Mainly on the junctions part, sir, because in India we don't have many, timer zones in streets, in normal streets, and normal streets also doesn't have a traffic light section as well. If we go to the small lanes.
Good. So be on the junctions only.
Yes,
okay,
sir.
Don't talk about the streets.
Yes, sir.
And then third question is CNN plus YOLO. By using these algorithms, you want to capture the image and you want to transfer it to the or convey to the traffic police.
Yes.
To change something.
Yes.
Have you observed in the junctions like MTL,
yes,
ATL? What do you mean by ATL, MTL?
I don't know the abbreviation, sir, but
because you are working on this particular area,
yes.
just you should know.
Yes, sir.
Right. And whatever you are saying, like capturing image and transferring to the or giving to the traffic police,
yes,
to change the lines.
Yes, sir.
Manually that is happening. Why do you require this particular algorithm or a model?
Can I answer that with an example, sir?
Please take a minute.
Yeah. So I'm telling that because let us take an example of an ambulance. If a person is in a dying state, he has to go through a lane or go through a way that may or may not have traffic in it. So with this, we can the YOLO algorithm will capture.
I don't think so. This example suits your. My question. Okay.
Sir, but you are asking me about capturing, right? So this will also capture that there is an ambulance and it has to go through and it has to go to ahead, right? It has to be the first priority of the traffic control because there's a person who is in a dying state. This will give him an input where is the ambulance and how to clear the traffic. If this is not present,
Nishant, you have to understand the question properly. Like
okay.
when you capture the image, are you capturing at the junction or in the street?
On the street, sir.
On the street, somewhere
Yeah,
else,
live.
not here.
No, sir.
But whenever a siren is there, automatically there is a gap.
Yes.
Okay, and the traffic police will encourage that particular ambulance to clear the route or to leave that particular route.
Yes,
right?
sir, but not
so
in
that is
every
happening.
single
That is
junction,
happening.
right?
Okay, that's happening. ठीक. Okay.
Thank you so much.
Any questions from the audience or Sarmeet? Do you have any question?
You have asked that.
Okay. Any questions from the audience? No? Okay. Right. Thank you.
Thank you so much for
So
giving me
next
this
speaker.
opportunity, sir.
Madam, please.
The next presenter.
బ్యాక్ ఎలా సార్ డిస్ప్లే అవ్వాలి ఆ యొక్క డిస్ప్లే కనెక్ట్ అవ్వాలి My project is automatic e-governance using artificial intelligence. These are the group members. Yeah, coming to the abstract, this abstract in olden days we have the government have to publish the policies. In that policies, a group of people will make the decision. Yeah, those group of people will make the decision with their own without knowing the ground reality. But we have come up with an idea that taking AI based e-government paving the. Yes, sir. I have forgotten to change the title. It is related, correlated, sir, but due to some constraint. Yeah, sir, but I have changed it, but it did not get reflected. It is correlated, sir. Yeah, sir, but it is correlated.
The work is correlated.
Yes, sir.
Correlated. Work is correlated, but not the one which you are going to what we have given here.
Yeah, sir. I know the title name, sir. I will explain. Oh, yeah.
The work is the same.
Yes, sir.
or
Same. Yes, sir.
Then why, how do you change the title of
Sir, due to some constraint, I have changed the title. Due to some constraints, I have changed the title.
what is the constraints?
Yeah, due to plagiarism constraints,
The
I have
title
changed.
itself is plagiarized.
No, sir. Actually, we have changed the title. We have changed the title and they have represented it. But at the last moment, they said we actually submitted for 3 other papers. They said multiple names of the title were repeated. The same
Yeah,
name.
that's why I have
So
changed
we had
it.
to change the name. And in the PPT, they have just forgot to update.
Yes, sir.
In this PPT, it is only different, sir. Everything
Yeah.
else is same.
Yeah. You just change it, otherwise you will
Yeah.
అదే చెప్పాను.
We have changed it, but it did not. I'll
Sure,
change.
that you have
Just
to
do
do
it
it.
now first. Don't ask.
Yeah.
UG projects like. Okay, the third presenter, secure, efficient and cloud-centric smart healthcare system with public visibility and Internet of Medical Things. Third presenter, please hand over the PPT.
Start. Good afternoon, panel members. My name is Fanindra. I am pursuing second MCA in KL University, Vijayawada. Today, my paper name is Secure and Efficient and Cloud-Centric and Smart Healthcare System with Public Visibility and the Internet of medical things. Those who are working in my paper, committee of 4 members. What is the paper defines? The collector of all IoT devices patients can store data in medical cloud center, which can handled by medical cloud authority. It is access to the client member and hospital who monitoring the patient's health, and the devices improved the patient care. How it uses? Collect and store the data of patient with the in the doctor storage data, and he can control and advise the patient who can remonitoring their health issues or anything in their daily life within their devices like a laptop, computer or mobile devices. Why it helps? Protect the patient privacy, because nowadays there are many illegal operations happen which can organ napping, that the device which is only protected to the policy of crypto's statement privacy, which has been more spend time on patient care. The system design of development cloud basic healthcare system. The 3 types of IoT device, the main part of Arduino devices or sensor devices, which can be help in the implants the human body with the cause of medical any causes. Medical cloud server, the all data of medical or patient, doctor or blood bank, everything can be stored in medical cloud server with the base of some rules. There are Capnophacy performance scale authority. These are normal authority which can implement rules of every medical patient privacy to only that prescriptional doctor or that hospital management. The IoT devices, some of IoT devices which are implants in the human body. One of the main devices had cardiac pacemakers, because the heart rate of every citizen can be decreased or increased with their common conditions. But some heart attack patients are there. First cause of their heart attack patient, they can second heart attack can be happen in any time, any situation. But it is but it can controls to notify when it is raised in it will firstly to inform or notify to the doctor or hospital management. As per the hospital management, the heart attack will be happen. Heart attack will happen. The doctor can instruction to the near the hospitals or blood banks or everywhere where he can enroll. Medical cloud server. The 3 types of servers we are used in the IoT device through medical cloud server, because Android device is purely generated with any software system only, because each and every application can run in the Android device to medical cloud server with the base of Bluetooth or server mapping or charge devising or every line parameter. Platform as a service. The main base of platform is cloud computing, which can be medical cloud server to enroll the personal details to video conferencing to video conferencing medical equipment or hospital server to another hospital to imitate patients to admit and cure the patient on them. Workflow of medical server. The medical server is deep, which is connected to all the medical associations or everything nearest to the medical hospitals or blood banks or ambulances, wherever. If a person can suffering from any implanted IoT device, suffering from any cause, anything, he can fall on one situation
I request the presenter to focus on your findings, not on the process which you are explaining us. What is your contribution for this research? That point you present to us.
Okay, sir. Sir, if any implant any implanted,
Your contribution in this. That
sir.
contribution you have to show. The results also you should show.
yes, sir. Sir, an implanted IoT device which a man or any heart attack man or brain tumor man can implant once they are operation or surgery on, cause there is only chances to only when he fall down or any cause and he taken to the hospital and regenerate the surgery, and after the taking of the IoT device what happened the doctor only knows. But according to my findings, if we have any notification or signal performance to through any cloud server, connecting in cloud server, it immediately generate to the he consent a doctor who is previously checked. Once he on, he can surely he can intimate the where the patients were held to surroundings of hospitals. He can inform the patient's details and every what did he can would have happened previous surgeries or anything he can explain, and the patient main tumor main cause he can explain to another doctor, then he will easier to surgery in without removing implantations or anything.
Have you implemented this project?
Yes, sir.
Have you implemented?
Yes, sir.
What is the result? How many patients your IoT device has been implemented or transplanted?
Sir, according to an world population survey.
No, I am talking about your contribution, not the
Sir,
others' contribution.
we are just executing program and the output of format can revealed, sir. That's why.
Now, what is your conclusion?
Every efficient cloud data that can easily to transfer one doctor to another doctor with the privacy of to not serving to another, not serving to another communities or anything, directly to another doctor to solve the problem of patient.
What is your name?
Fanindra, sir.
Fanindra.
Yes, sir.
In this work, like you have implemented something, right? In which platform you have implemented this? Which platform or which programming language you have used?
Python, sir.
Python.
Yes, sir.
Okay. So, what is the actual work you did? What is the actual work you have concentrated on?
Sir, my actual work, total cloud server with the total cloud server can manage one hospital or one doctor can manage cancer or hospital
Cloud
manage.
server has to be managed by the doctors?
So that means a patient data.
Patient?
Only only he only he treats patients can he can see all the data or anything.
You mean to say like he can check,
Mm.
he can see
Yes,
the
sir.
reports
Only
in the
his
centralized database,
Only his
like a cloud.
yes, sir.
Okay. Anything else in that?
No, sir.
Nothing.
Yes.
Okay. Okay. Right.
Thank you, sir.
Sorry. Any questions from the audience, please? No questions? Okay. Then next
you, sir.
participant or next presenter, please.